Okay, today's lesson is over section 5.4. Section 5.4, we are going to learn how to take the derivative of e to the x and e to the u. E to the x is the inverse function of the natural log of x. So y equals natural log of x, which we've already learned how to take the derivative of, and y equals e to the x are inverse functions. So what that means is if I take the natural log of e to the x, I will get x, or if I have e to the natural log of x, I will also get x. That is because those two are inverse functions of one another. Now let's just review for a second how you solve different problems involving e to the x. For example, if I have 7 equals e to the x plus 1, and I want to solve for x. To do that, I will take the natural log of both sides. So I'll say natural log of 7 equals the natural log of e to the x plus 1. And the reason why I do that is because now natural log of e raised to x plus 1 is just the same thing as x plus 1. That will equal natural log of 7, and then you subtract 1, so the natural log of 7 minus 1 will equal x. So hopefully you remember that from your pre-calculus class. Another example of a pre-calculus topic would be solving natural log of 2x minus 3 equals 5. That's 2x minus 3 equals 5. This is logarithmic form. To solve for the x, you need to change it to exponential form. So my base is e, so I am going to say e raised to the 5th equals 2x minus 3. You will remember it from doing the loop. Take the base, raise it to what's over here on the right-hand side of the equal sign, and set it equal to whatever the natural log is to. So remember the loop. So e to the 5th equals 2x minus 3. Well, now it's easy to solve for x. So I will say e to the 5th plus 3 all over 2 will equal x. Okay, so that's using our natural log function and our e function together to go back and forth between the two. You can write it as a natural log problem, or you can write it as an exponential function. Okay, the graph of e to the x, you want to be familiar with it. So y equals e to the x. You may want to look at some of these on your calculator. It is going to go through the point 0, 1. Remember, natural log of x goes through the point 1, 0. So since it's the inverse, it'll go through the opposite points. But this graph will look like that. The domain is all real numbers. You can plug anything you want to in for x. So domain is all reals. And then the range are going to be the values y greater than or equal, just greater than 0. So y greater than 0. It is going to infinity as x goes to infinity. Okay, so you want to be familiar with that graph as well as the natural log of x. Okay, so let's now get into some of the calculus problems that we're going to do. Let's start off with the rule. The derivative of e to the x is equal to e to the x. You're not going to get much simpler than that. So the derivative of e to the u is u prime e to the u. So that is your rule. Let's look at a couple of example problems. So if my function is y equals e to the 2x minus 1, my derivative function will be 2e to the 2x minus 1. Okay, you might have to use it with a product rule. So if my problem is y equals 2x squared times e to the 3x, how are we going to take the derivative of that? That's an x. We are going to use the product rule. So we do the first times the derivative of e to the 3x, which is 3e to the 3x, plus the second, e to the 3x, times the derivative of the first, which is 4x. So you just apply the rule to whatever problem that you are working. The integral of e to the x, of course, is e to the x. If it is an e to the u, anything other than just plain old x, you are going to have to write out what your u is so that you can see if it's going to have a coefficient. So let's do an example. The integral of e to the 3x plus 1. Well, our u is going to be 3x plus 1. The derivative of that is 3. I only want it to be 1, so I divide both sides by 3. And I put it in the problem in u in terms of u. So this is going to be 1/3 integral of e to the u du. Well, my formula says the integral of e to the u is e to the u. So my answer will be 1/3 e to the 3x plus 1 plus c. Okay, so make sure you write out your u, even though it seems fairly simple. The other kind of integral that's going to involve e to the u is if there's two e's in the problem, which is going to make your u a little bit different. So let me come up with an example problem here. If we have to take the integral of e to the 2x over 1 plus e to the 2x dx. There's two e's in that problem. So you have to decide what's going to be your u. If there are two e's in the problem, your u is going to be the denominator. So u is going to equal 1 plus e to the 2x. My derivative is 2e to the 2x dx, or 1/2 du equals e to the 2x dx. Now I make my substitutions. So when I substitute, my problem is going to look like 1/2 the integral of 1 over u du. What is the integral of 1 over u du? From section 5.2, you learned that it is the natural log of the absolute value of u. And our u was 1 plus e to the 2x, and then we add our plus c. Okay, I think that wraps it up for section 5.4. I would like you to try a couple problems. So on page 351, 357. Actually, let's start on page 356. I would like for you to do number 10, and then number 38, and also number 86. Good luck, and I'll see you in class tomorrow.